Magandang araw! I hope everyone who is watching this video is safe, healthy, and happy. Now, this learning video is about electrochemistry. So, it is the study of the interconversion of electrical and chemical energy. The conversion takes place in an electrochemical cell, which could either be voltaic cell or an electrolytic cell. When a spontaneous chemical reaction generates electrical energy, then the electrochemical cell is called voltaic. No? When an electrical energy is needed to bring about a non-spontaneous chemical reaction, then we have an electrolytic cell. Now, the reaction taking place in both, no, whether voltaic rather, or electrolytic cell is of the oxidation reduction type. So, alalahanin, ano na nga ba yung oxidation reduction? So, tinatawag nating redox, no? So, ano yun? Yung may energy, electron loss, electron gain. Okay? Now, in an electrochemical cell, we have one electrode, which we call the cathode, where a reduction half reaction occurs and electrons are consumed. So, we have here an example. Cu positive 2 in aqueous solution, meaning in solution with water, no? Plus 2 electrons will form or is reduced rather to Cu solid. So from positive 2, bumaba, na-reduce to 0. Similarly, chlorine gas plus 2 electrons forms 2 chloride ions rather in aqueous solution. So Cl2, 0 is reduced to negative 1. So again, a reduction. Why? Because electrons are consumed or gained. At the other electrode, which we call the anode, an oxidation half reaction occurs. Here, electrons are produced. So, madali namang tandaan. Anode, oxidation, parehong vowel yung umpisang letter. Yung cathode, tsaka reduction, pareho namang consonant. Okay? So, ano nangyayari sa anode? So, yung zinc, tumaas ang oxidation state, no? From zinc 0 to zinc positive 2. So, we have zinc atom or zinc solid forming is oxidized to zinc positive 2 with the release of 2 electrons. Okay? And then we have 2 iodide in aqueous solution is oxidized to iodine. So from negative 1 to 0. So tumaas ang oxidation number with the production or the release also of 2 electrons. Now, one of the most important characteristics of a cell is its voltage. Ano ba yun? A voltage is a measure of a reaction spontaneity. Spontaneous ba o hindi yung reaction? Sabihin, cell voltages depend upon the nature of the half reactions occurring at the electrodes and upon the concentrations of species involved. From the voltage measured at standard concentrations, it is possible for us to calculate the standard free energy change and the equilibrium constant of the reaction involved, although this video will just focus on cell voltages. Now, let's discuss a bit more about voltaic cells. A spontaneous redox reaction can serve as a source of energy in a voltaic cell. So, alam na natin yan, ano? So, pwede tayong makakuha ng nag-generate na electrical energy nung spontaneous redox reaction na yun. Now, the cell must be designed such that oxidation occurs at the anode while reduction at the cathode. So, kailangan tama yung pag-design natin ng ating cell, no? The electrons produced at the anode must be transferred to the cathode where they are consumed. Now, to do this, the electrons move through an external circuit where they do electrical work. Kasi kung napoproduce nga yung electrons, tapos nag-stay lang din siya doon sa lugar na yun, wala namang mangyayari, di ba? Alam natin na yung electricity is because of the movement of electrons. So, dapat nag-move, gumagalaw yung electrons. So, may transfer, no, from one point to another point. Okay, so how do we do that? So ito meron tayong zinc metal, no, nakalubog sa copper sulfate solution, no, aqueous solution. So yung copper sulfate aqueous solution kulay blue, yung Cu positive 2 ang cause ng kulay na yon. Now pagka nagkaroon ng contact yung zinc metal at saka yung copper sulfate solution, ano nangyayari? Nagkakaroon ng redox, no, kasi spontaneous na yun. So, nagkakaroon ng anode where zinc is oxidized, releasing 2 electrons. Tapos sa cathode, there is reduction where copper is reduced from Cu positive 2 to Cu because it gained 2 electrons. So this is the overall reaction, redox reaction. Now, how do we design a voltaic cell using the zinc-copper reaction as a source of electrical energy? The electron transfer must occur indirectly. That is, electrons given off or electrons produced by zinc atoms must be made to pass through an external circuit before they reduce Cu positive 2 ions into copper atoms. One way to do this is by preparing a setup similar to this one. Here, the voltaic cell consists of 2 half cells. 2 half cells. Ano yun? Ito yung zinc anode. Ito yung zinc to. Zinc to. Tapos, saan siya nakalagay? So, dip sa solution containing zinc positive 2 ions. Here, we have the copper cathode. So the zinc is the anode. Copper is the cathode. Lubog naman siya sa solution ng copper sulfate, kulay blue. And then you have a voltmeter. So, nangyayari na yung sinabi ko, ito yung zinc kulay red, yung copper kulay itim. Okay, so ito yung anode, ito yung cathode. So, sa anode nakaka-produce ng mga electrons, So, the zinc anode pumps, Yung napoproduce na electrons dito, pinapump ng electrode papunta doon. Ito naman, etong copper cathode, parang hinihila niya naman, pinupull niya naman yung mga electrons. So, hindi nahihirapan yung mga electrons mag-travel from this point to this point. Okay. As the half reactions proceed, a surplus of the positive ions tends to build up around the zinc electrode. The region around the copper electrode naman tends to become deficient in positive ions as Cu positive 2 ions are consumed. Remember, nare-reduce yung Cu positive 2 nagiging Cu. Tapos ito naman, nagbi-build up ng Zn positive 2. O, ano na nangyayari doon? Nagkakaroon ng surplus, diba, ng mga ions. To maintain electrical neutrality, cations must move toward the copper cathode. Dapat pumunta sa copper cathode. And alternatively, ions must move toward the zinc anode. Now, in practice, both migrations occur simultaneously. So, the migration occurs in a salt bridge. Ito yung salt bridge na sinasabi. It consists of an inverted U-tube plugged with glass wool at each end. And the tube is filled with a solution of a salt, also a salt that takes no part in the electrode reaction. So, hindi siya nakikialam doon sa oxidation reaction sa anode at saka sa cathode. So, for example, we have here potassium nitrate. As current is drawn from the cell, pagka nagkaroon ng kuryente, potassium ions move from the salt bridge into the cathode. So, dito, cathode. At the same time, nitrate ions move into the anode half cell. So, dito naman. That way, so yung napoproduce na zinc positive dito, nanoneutralize ng mga nitrate ions. Diba? Yun ang nangyayari. This way, electrical neutrality, as I mentioned, is maintained without copper ions coming into contact with the zinc electrode. Okay? Otherwise, nagkakaroon ng short circuit. Now, we have here a cell notation. Cell notation. So, on the left, we have the anode or the oxidation reaction. And on the right side, the reaction at the cathode or the reduction. So, zinc is oxidized from 0 to positive 2. Copper is reduced from positive 2 to 0. So, notice yung reduction nasi-separate ng single bar. Tapos, yung oxidation tsaka reduction separate naman ng 2 bars. Okay, kaya na yung sinasabi ko. Basahin nyo na lang. Now, there are other salt bridge cells. Okay? So, mayroon tayo dito another spontaneous reaction between nickel and copper. So, ano nangyari? Nickel is oxidized from 0 to positive 2 and copper is also reduced from positive 2 to 0. Okay? So, ano yung salt na ginagamit? Nickel chloride or nickel sulfate. So, meron tayong copper electrode at saka nickel electrode. So, di ba kanina zinc at saka copper? Ngayon naman, nickel at saka yung copper. So, nasa anode si nickel, nasa cathode si copper. Another spontaneous reaction between zinc and hydrogen ion forming zinc positive 2 ions and hydrogen. So take note that one of the species is a metal. O paano ngayon yan? Di ba dapat dalawa yung electrodes? In cases like this, we use inert electrode, no? So in this particular example, we use platinum. So, di ba kanina, zinc, copper, nickel, copper. Ngayon, zinc and platinum. Pero ano nangyayari? Ang nare-reduce yung hydrogen, no? Yung gas. Kaya nagbabubble out yung hydrogen. Kasi yung platinum inert. Ano ibig sabihin ng inert? Highly unreactive. Okay? So what happens? Hydrogen gas is bubbled over the cathode, which is surrounded by hydrogen ions from a solution of HCl. Okay? So ano nangyayari? Anode oxidation takes place. So zinc is oxidized. So zinc 0 to zinc positive 2 because it lost 2 electrons. Cathode reduction takes place, no? So 2 hydrogen ions plus 2 electrons, no? Yung nanggaling na electrons doon sa zinc forming hydrogen gas. So this is the cell notation. So this is where oxidation takes place. Zinc is oxidized, zinc to zinc positive 2 separated by a single bar. Then oxidation is separated with the reduction by the double bar. So here, hydrogen is reduced, H positive to H20. No? So ano to? Ano yan ma'am? Panggulo. So this indicates that we used a platinum electrode. Okay, so inert platinum electrode. Okay, so another example. So here, when chlorine gas, no? So chlorine gas is bubbled through a water solution of sodium bromide, a spontaneous redox reaction occurs. So chlorine, o tingnan na lang natin yung reaction. So, yung chlorine 0 naging negative 1. So, na-reduce, no? Kitang-kita, chlorine is reduced from 0 to negative 1. Sa madaling salita, itong Br negative 1 is oxidized dahil tumaas ang kanyang oxidation state from negative 1 to 0. So, madali lang sagutin to. What is the cathode reaction, the anode reaction, which way do electrons move, which way do anions move? So, yung cathode, that is where reduction takes place. So, yung bumaba yung oxidation state. So, ano yun? Yung Cl2 ang makikita mo doon. Sa anode, yung na-oxidize, yung tumaas yung oxidation state. So, bromine ang makikita mo doon. Which way do electrons move? No? Saan ba napoproduce yung electrons? Saan napoproduce ang electrons? Okay? Ayan, sa anode. No? Sa anode. So, dito. No? So, sa anode, dahil nandun yung oxidation, yung mga species doon, naglo-lose ng electrons. So, maraming mga electrons dito. So, we would expect electrons move from left to right. No? Ayan, nakikita nyo naman yung direction. Okay? So, ito yung reaction sa cathode where reduction takes place. Chlorine gains 2 electrons to form 2 chloride ions in aqueous solution. In the anode is where oxidation takes place. Bromine is oxidized. Bromide rather is oxidized. Bromide negative 1 to bromine 0 with the release of 2 electrons. So we know that electrons move from the anode to the cathode, that is from left to right. And ions move to the anode, no? And then cations move to the cathode. Now let's discuss about standard voltages, which is the driving force, no? The driving force behind a spontaneous reaction is measured by the cell voltage, which is an intensive property. We recall sa general chemistry yung intensive at saka intensive or intrinsic property, no, as opposed to extensive or extrinsic, no. So ito ibig sabihin intensive independent of the number of electrons passing through the cell. The cell voltage depends upon the nature of the redox reaction and the concentrations of the species involved. Okay? The standard voltage for a given cell is that measured when the current flow is essentially 0 and all ions and molecules in solutions are at concentration of 1 molar. So recall ano ba yung 1 molar? Molarity. 1 mole of solute per liter of solution. Okay? So liter of solution na. So in our case earlier, yung copper sulfate, 1 mole of copper sulfate in 1 liter of solution. So that is volume ng solute plus water. And what else? All gases are at pressure of 1 atmosphere. So for example, we have here the zinc hydrogen ion cell. Now suppose the half cells are set up such that the concentrations of zinc positive 2 and H positive are both 1 molar and the pressure of hydrogen is 1 atmosphere. Under these conditions, the cell voltage at very low current flow is positive 0.762 voltage. So determine yan experimentally. Di ba kanina merong a voltmeter. So yun, nagre-register 0.762 voltage. This quantity is referred to as the standard voltage or standard potential. Pareho lang yun voltage and potential. And is given the symbol, ayan, E superscript 0. Pag nakakita yan, ibig sabihin yun yung standard potential or standard voltage nung buong reaction. Okay, so in this case, sa oxidation ng zinc at reduction ng hydrogen ion, ito yung mga products. So, ang standard voltage or standard potential is positive 0.762 volt. Okay, ano naman tong E superscript ox and E superscript red? So, ibig sabihin, standard voltage for oxidation and standard voltage for reduction. Ibig sabihin, yung standard potential or standard voltage in the half cell reaction. Okay? So, ang sinasabi dito, yung dalawang yon, pag pinagsama mo, equal siya sa standard voltage or standard potential. Okay? So, kung i-interpret natin yung reaction natin kanina, yung zinc hydrogen, so yung standard voltage or standard potential na 0.762 volt, that is the sum actually of the half cell, no? So yung oxidation at saka yung reduction. Okay, now there is no way for us to measure the standard voltage for a half reaction. Only the standard potential or the standard voltage yung sa buong reaction is measured directly. Now, how do we obtain values for the standard potential or voltages for half reactions? O yung E superscript ox and then red reduction. So, paano ginagawa? The value 0 is arbitrarily assigned to the standard voltage for reduction of hydrogen plus ions into hydrogen gas. So, inassign, no? Inassign. So, itong reaction na to is itong reduction na to, ang value niya ay 0. Tapos lahat i-compare siya. Okay? Now, using this convention, it follows that the standard voltage for the oxidation of zinc must be 0.762. Di ba kasi kanina, itong reduction kanina, yung zinc, na-oxidize yung zinc to zinc positive 2, hydrogen ion is reduced to hydrogen 0. Di ba kanina 0.762? Kung 0 yung hydrogen, ibig sabihin lahat yun ay galing sa zinc. No? So yung oxidation potential ay 0.762. Okay? So yun ang mapoproduce na energy. No? Okay. Now, as soon as one half reaction voltage is established, the other can be determined. Kasi sabi nga natin, we cannot obtain yung voltages ng half reactions. They cannot be measured directly. Ang na-measure lang natin yung buong reaction. Pero kung alam mo na yung voltage ng isang half reaction, malalaman mo na yung isa dahil doon sa equation kanina, no, na yung standard potential or standard voltage is simply the sum of the potential for reduction plus the potential for oxidation. So yung kanina, yung zinc copper, for example, the standard voltage for the oxidation of zinc copper is 1.101 volt. Knowing the half cell potential oxidation for zinc 0.762, malalaman natin yung reduction potential ng copper. So isubtract lang natin. No? So ito yung standard potential, meaning yung the whole reaction. Ito yung sa oxidation ng zinc. Therefore, yung reduction ay 0.339 volt. Okay. Now, standard half cell voltages are ordinarily obtained from standard potentials. No? So, yung standard potential is equal to the standard potential for reduction. So, merong table niyan. The potentials listed later on, I will show you, are the standard voltages for reduction half reactions. Okay? For example, since the standard potential in the table, ayan, yung reduction ng zinc, no? Ito, reduction ng zinc, negative point. Di ba kanina positive kasi na-oxidize siya. So, pareho lang sila ng value, magkaiba lang ng sign. Ito naman yung reduction ng copper from positive to 0, no? 0.339. Now, standard voltages for oxidation half reactions are obtained, ito yung sinabi ko, by changing the sign of the standard potential listed. Kasi yung mga binibigay sa libro, yung mga tables ay for reduction. So, masosolve, babaliktarin mo lang yun na yung for oxidation. Okay? So, in general, standard voltages for forward and reverse half reactions are equal in magnitude but opposite in sign. So, kunwari, ang given ay halimbawa reduction, tapos kailangan mo oxidation, palitan mo lang yung sign, yun din yung value. Okay? Let's discuss now about the strength of oxidizing and reducing agents. No? Recall, an oxidation agent is a species that can gain electrons. It is a reactant in a reduction half reaction. Okay? So, oxidation, ano nga yun? There is loss of electrons. Yung substance ay nag-increase ng oxidation number, no? Katulad ng zinc kanina, 0 to positive 2. Siya yung reducing agent. Okay? So, baliktad naman yung oxidizing agent sa reduction. Okay? A strong oxidizing agent has a strong attraction for electrons and can readily oxidize other species. The strength of an oxidizing agent is directly related to the standard voltage for its reduction. O, tingnan nyo ha. Reduction potential yung binibigay, value ng reduction potential. Pero, equal siya sa property ng pagiging oxidizing agent, powerful. No? So, the more positive the standard potential for reduction is, the stronger the oxidizing agent. Tandaan yun. So, there is a direct proportionality. No? Pag mas mataas yung standard voltage for reduction or standard potential for reduction, better oxidizing agent yun. So, ito yung table. Ito lang yung nakuha ko. No? So, stronger oxidizing agent. So, sa list dito, yung fluorine, yung oxidizing agent. So, pataas, stronger oxidizing agent. So, baba, weakest oxidizing agent. So, ang weakest oxidation agent dito sa table na to ay lithium at ang strongest ay fluorine. Kaya ang fluorine, hindi siya ginagamit. No, in solution to, in aqueous solution, hindi siya ginagamit kasi fluorine takes electrons, no, sa lahat ng nakapaligid sa kanya with explosive violence. So, hindi siya ginagamit. Normally, ang ginagamit, ito, fluorine at saka yung dichromate, no? Yung mga bleaching agent, yung mga ginagamit yung oxidizing agent sa bahay, normally chlorine yun. Okay, so, compare mo lang, pagka mas mataas, no? So, pansinin nyo, positive yung reduction potential, no? Positive, okay? So, habang tumataas yung value ng reduction potential, tumataas yung pagiging oxidizing agent. Tama ba yun? Tumataas yung power. Nagiging strong, ayun, oxidizing agent. So, yun na lang tandaan nyo. The other one holds, pag reduction naman, pabaliktad naman yun. So, halimbawa, we are given this list of species, no? Dichromate, bromide, magnesium, and Sn positive 2. Let us arrange in order of increasing strength as oxidizing agent. So, ano lang gagawin mo? Kunin mo lang yung mga values ng reduction potential. No? Tapos, i-compare mo. Ano yung sabi? The higher the value, the stronger as oxidizing agent. So, obviously, yung dichromate yung pinakamataas. Susunod yung Sn, no? Kasi siya yung pinakamababang negative. And then, bromide. At ang pinakamababa ang oxidizing power ay magnesium. Ibig sabihin, yung magnesium naman ang strongest reducing agent. Alright. How do we calculate? No? Given naman, halimbawa naman, given ang standard potential ng oxidation at saka reduction, we can compute for the standard potential of the reaction. So, paano yun? For example, we are asked to calculate for the standard potential for the Voltaic cell in which the reaction is, yun, we have 2Fe positive 3 plus 2 iodide both in aqueous solution. So, iron is reduced, no, from positive 3 to positive 2. So, yun yung cathode, nasa cathode. Ito naman, iodine ay tumaas, iodide, no, from negative 1 to 0. Nag-release kasi siya ng electron. So, yun naman ang nasa anode. No? So, ito yung reduction reaction, ito yung oxidation. So, wala tayong pakialam ngayon sa anode tsaka sa cathode. No? Basta reduction reaction na lang tsaka oxidation reaction. So, yung reduction, saan galing yan, ma'am? Inimbento mo, hindi, dun sa table. No? Kunin lang sa table. So, yung Fe positive, 3.77 volt. Yung iodide to iodine ay negative 0.54. So, yun yung oxidation. So, tingnan nyo lang, oh, halimbawa, nagkabaliktad yan, tapos ang nakalagay doon, reduction, babaliktad din nyo lang. Kunwari, ito ay oxidation, no? Papalitan nyo lang yung sign. Ha? Yun lang ang babantayan nyo. And then, you just add the two. And then, the sum is 0.23 volt. Ibig sabihin, yung standard potential for this redox reaction is 0.23 volt. Okay? So, that's it. Thank you for listening. I hope malinaw, parang 26 minutes, ano, at least less than 30 minutes. Sobrang binilisan ko na nga kasi medyo mahaba itong topic na to. Gusto ko sana mas maikse para hindi kayo sumasakit ang mata at naiinip sa panonood. So, in the meantime, you stay safe and you stay healthy. I will stop sharing now and I will also stop recording and I'll see you in the next video. Bye for now.